So this video is going to show you just discreetly how to take any image in Photoshop and apply a halftone via Bitmap. Bitmap will be the only method of achieving a halftone where you can see the halftone on the computer screen before you actually print your film positive on the laser printer. There is another method of creating a halftone um, that I can show in a different video. However, for my Print 1 students, my Intro to Print students, the bitmap method shown in this video is how you should achieve a halftone if you want it. So first off, this image, it's a riff off of that classic Boston cover art, is currently a color image. So the first thing I need to do is to put it into grayscale. So image mode. RGB color mode is of course the default for almost all JPEGs because that's how the computer screen wants to show it as RGB light color space. So we have to switch it up to here to grayscale. So we choose that and we're going to go ahead and let it merge the layers. Discard that. So now we have this. One of the things to keep in mind about Bitmap is it tends to darken the image and lower contrast. So even looking at this now with the lack of color information, it gets maybe a little dark. So what I might want to do is come over here and do an adjustment layer. And I like to do it with curves. You can do it with curves, levels, or with brightness contrast, but curves kind of gives you the most control. It's just that people are intimidated by this histogram here. But let's say I want to lighten the image while also increasing the contrast. And I want to do it slightly past what looks appropriate on the computer screen, knowing that once I bring this into Bitmap, it's going to darken and lower contrast. So on this histogram, the bottom left corner is all the whites in the image, and the top right are all the blacks in the image. And you see this graph is expressing how much of each value you have in the image. And you can see this spike of values. So you see we've got a whole bunch of really dark grays. We've got another spike just past middle, just darker of middle gray. And we've got almost no white in the image, a little bit of white in here. But the image itself relied on color a lot to be readable. And so now we're having to contend with it just in black and white. So what I want to do is I want to make a classic S-curve. So I don't really need this to be much darker. So normally what I do for it, just to increase the contrast on a curve, is I would click here and drag up a little bit. So I'd make the dark grays darker. And I do an equal kind of click down here and drag it down to make the light grays lighter. The problem is that a classic S-curve, a curve that would probably work great for most other images, is making this too dark. So I did in fact increase the contrast, but it's making it a bit too dark. So I just need to click on this one again, bring it back down to something normal, and maybe even a little bit past. I need more variation in my dark grays, and so I'm starting to see it there. That's much better. So that is a hair lighter than I probably want it to be, just a tiny bit. So I'm going to make it that tiny bit lighter than I think I want it to be, knowing that it's probably going to get a little darker as I take it into Bitmap. I like to do this as an adjustment layer. It shows up as a separate layer because I'm not actually doing it to the main layer then. So if I don't like it, it's easy to just discard. But then if I like it, I could come up here and to layer and just do flatten image. Okay, done. So next, from Bitmap, we can go to, well, first we need to check image size. That's the next thing to do. So we go here, image size, and we see that while dimensionally fairly large, it's actually only 72 pixels per inch, which is not large. That's because I pulled this image offline as a simple image search. So let's do this. Let's unclick resample and let's up this to 300. Well, let's do this. Let's do 150. And so that gives us this 5, roughly a little over 5 by almost 8 inches at 150 pixels per inch PPI, and that's all adequate. That, for this demo, that size is fine. That's going to fit on the film positive paper that I can run through the laser printer, which is 11 by 17. So we're good. Okay, so nothing actually changes because all we did was change the ratio of pixels to inch. We didn't actually change the size of the image, so we're not trying to add resolution, nor did we delete information. We just changed the relationship between those two. So now our image size is set. Here, we're good. We're almost 8 inches by a little over 5 inches, 150 PPI. And 150 PPI is probably the minimum you want to have for a thing like this, which is not high, but since we're going to do the halftone, we don't need super high resolution. 150 will be fine. And it's important to understand, too, that with the halftone, you're talking about dots per inch, which we refer to as DPI or LPI. DPI and LPI are the same thing, but pixels per inch we refer to as PPI, and PPI is very different than DPI. So pixels per inch, you're talking about how the computer remembers the image. It's a grid of pixels, and if I zoom in, I see those square pixels that each have their own gray. Dots per inch, you're not talking about digital information at all. You're talking about ink on paper. And so dots per inch, it's a very different arena, different problem that is solved. And so with this, the reason we need the halftone is because within all these grays, this would not translate to the screen, right? So this area right here might be dark enough to block the light when we expose our screen, but moving over to these other grays, like these grays would not be dark enough, and it would depend on the exposure under your screen. But very likely, light would start to get through here. And there's always going to be a tipping point. So all of this would disappear, most of this would disappear, and there'd be this edge somewhere in here, and that edge would be fairly sharp as it goes from exposed emulsion to unexposed emulsion. So the richness and articulation of all of this just disappears. It's gone. Everything goes to either black or white. So we need a halftone to translate those grays. Once translated, it's not going to be exactly as you see here, but it'll be closer than if we simply printed this out and tried to expose the screen with this. So let's back up. It's the whole image. So now we have flattened the image. We've set the curves to a slightly brighter, slightly higher contrast. We've checked the image size, and we know that it's the size that we want. We're finally ready to go image mode bitmap. And note that you cannot go to bitmap mode from anything except grayscale. So if you are in RGB, it won't give you the option of choosing bitmap. You can only choose bitmap from grayscale. Okay? So I choose bitmap, and I get this dialog box. The first one tells me I'm bringing in an image that is 150 pixels per inch. Do I want to keep it that way? Now, in some cases I might want to keep it, but in this case, because I want a halftone, I do not want to keep it. I want to raise it up. And but in order to make the point of why I need to raise it up, I'm going to leave it that way for a minute. And I'll back out and do it again, and I'll show you something. And then right here, in these options, I want to choose halftone screen. Right there. That's all I do on this, is I stipulate how many pixels per inch I want in the bitmap file, and I stipulate that I want halftone screen, and I click OK. And because I chose halftone screen, it gives me this dialog box. Now here it's saying lines per inch, and remember, lines per inch and dots per inch are the same, and in either one we're talking about ink on paper. We're talking about dots, we're not talking about pixels. Now we are limited by what size dot the screen can hold consistently. The higher this number is, the smaller the dots are going to be, because it's quite literal, lines or dots per inch. So if this number is very high, then we're packing in more dots in a linear inch than if that number is very low. So just like thread count in your sheets and blah, 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 a higher number here means smaller dots. It is quite possible to get to a dot size that is too small for your mesh to hold on to and to translate and to allow to print. And that'll cause a whole bunch of weird stuff to happen in your print. It will depend somewhat on mesh count, but your screens that you're using are 195 threads per inch. And so with that, the maximum LPI or DPI that you can do is 35. Now you can do lower than 35, but 35 is the highest. Okay? So don't do anything higher than 35 for right now. The angle, I would probably say leave at 45. That's the default for a grayscale. Doesn't have to be, but the dot goes down in a grid. All the dots in the halftone do. And so because it's a grid, inevitably there's an angle to that grid. So anyway, just generally leave that at 45. If you're doing 35 dots per inch, that's effectively trying to maximize detail. And so choose ellipse. You might want to choose round or line, or try one of these others, especially if your DPI starts to get low, like 10 to 25 dots per inch. At 10 to 25, the elliptical nature of the dot will be visible. And so sometimes people choose round because they want their dots to be round for that reason. But at 35 dots per inch, you will not be able to discern with your naked eye that the dot is elliptical, but the ellipse is better for your screen. So if we're trying to maximize detail, we choose ellipse. If this gets low and we're not trying to maximize detail of the photograph and instead trying to emphasize the dot, then we tend to choose round or line or whatever you want in here. So choosing ellipse, we hit OK. And there is our halftone. Except I just gave you this discussion about an elliptical dot shape. And as I zoom in, you might be asking, there's nothing elliptical about anything that we're looking at. And that's true. So why is that? That's because I came into Bitmap with 150 pixels per inch. So this is the computer trying to translate an elliptical dot, but at too low of a pixels per inch resolution. And thus we get what we call stair-stepping of the square pixels. And also note that Bitmap is a mode in which all pixels are either black or white. There will be no more gray pixels in Bitmap. And it's just the dispersal of those pixels that starts to create the grays. So I'm going to Command Z that. Command Z, back. So I'm back at Grayscale now. So let's just do that again. Image, Mode, Bitmap. But instead of leaving this at 150, let's do 600 and leave everything else the same. 35, 45, ellipse, and zoom in. And you see that we're now quite different. So now you can see the elliptical nature of the dots. You can still see the stair stepping, but they are so small that the naked eye in the print will not notice that these ellipses are composed of little dots, little squares in a grid. Instead, they will actually look like ellipses. Like this is like if I view it actual size, like that's depending on the screen you're viewing it at, but that's like actual size, right? Something like that, something in this vicinity. So you might be able to discern that it's a dot, but you won't be able to see the stair stepping. Whereas in the previous version, the image really looked very different. Also, those big square chunky pixels can get kind of weird as you expose that onto your screen too. So this is much better. So 150 pixels per inch is fine for what you're working on digitally, but just for the bitmap mode, you need to raise it up to 600 pixels per inch, if for no other reason than avoiding crazy stair stepping in your dot size. Okay? So let me show you a few other options. This, of course, is 35 dots per inch in any linear inch of the image. And I'm going to show you some different possibilities. So I'm going to Command Z, back to the grayscale, image, mode, bitmap. I'm going to leave that at 600, leave it at halftone screen. And let's change this to 20 instead of 45, or instead of 35. So you see that the dot is much larger now. And consequently, we're getting less articulation in the subtle areas. It's harder to read the type. The stars in the background are harder to read. Okay, I'm going to Command Z. I'm going to do that again. Image, mode, bitmap, 600, halftone. But instead of 20, let's do 10. Really big dots. So you have to kind of ask yourself, is my goal to translate the original image, or is my goal to have fun with dots and the language of print? Both are fine, but it's really about what you want to do. Command Z, image, mode, bitmap, leave it at 600, leave it at halftone screen, but instead of having it super low, let's put it at 25, but instead of ellipse, let's choose line. See what line gives us. Oh, so this works by virtue of the fact that the lines, which the center of each line is all equidistant to the next, but the thickness of the line varies to create the sense of value. Isn't that awesome? It's magical. So the more I zoom out and the more you see it on a small scale, oh, there you're getting some more the less you see the lines, and the more you see it just as gray value. And that's how any of these things work, is the human eye becomes bad at seeing individual lines or dots when they're small enough, and instead our brain generalizes what we're seeing into, in this case, a value, a gray value. So line is fine if you want to incorporate line. I'm going to Command Z. You can also play with the angle, image, mode, bitmap. Leave all that the same. Leave that the same, but let's change the angle to 0. Now we have horizontal lines. 90 degrees would be vertical lines. We had 45. At a 45, you could do whatever you want on that 360-degree scale. Command Z. Image, mode, bitmap. Leave all that the same. Try anything else that you want. Try the square and see what happens. Here it puts these squares in, but the squares are different sizes to convey the different values. So again, this is a digital addition to the potential tools that came only with the computer, whereas the halftone and the lines were something that predated the computer by many, many decades. But any of these are open to you. These are just ways of translating value from a complex gradient image into a screen print, which has to be either or, has to be high contrast. And so all of these options that I'm showing you are essentially high contrast because everything is either black or white. It achieves the value by virtue of the density of these bits of information, not by actual gray pixels. And so we can rely more on that this any one square is going to be opaque and block the light so that this will print in my screen print and these white areas will not. Quite simple. Now let me show you one other set of options with this. So I'm going to Command Z this, and that is if I don't choose halftone screen at all. I can choose Diffusion Dither. Now the essence of what Diffusion Dither is instead of a grid of dots, the computer is going to provide me with a somewhat random dispersal of square pixels. So in this case, I cannot go in with 600 ppi. In fact, I have to lower it to about 120. Because in this case, the number of pixels per inch determines the size of the black squares that I'm going to have in my film positive and thus in my screen print. So only if I'm choosing Diffusion Dither do I need this very low at 120. And clicking OK, so you see that now it's translating the image in a very different way. I still have everything either black and white, but you see that the values are translated into this different system where the squares are somewhat randomly dispersed. They are denser in the dark areas and they are more dispersed and rare in the light areas, but they're not in a perfect grid to each other. Now it's not a true random, nor is it the best translation of value. So you're welcome to use this, but know that it's got its own limitations in terms of translation of value and also detail. So maybe the detail is not quite as good in here. But just to give you an idea, so let me Command Z, if I went in and chose Diffusion Dither, but I left this at 600, or if I put it up to 600, I might think, oh, that looks pretty good. I like the way that looks. Why not do that? Well, the problem with this is that my little black pixels are now so small because I'm packing in 600 to a linear inch instead of 120 that these will almost all disappear as I expose them onto the screen. Again, what will happen is these white ones are too small to allow the light through, so this is going to go to solid black. These are too small to really block the light, so this is going to go to almost white. This will all disappear and go to completely white. So it's about how predictable my image is going to translate from the computer to the screen print. What you're seeing here at 600 pixels per inch Diffusion Dither will not translate very accurately. In fact, it'll be very inaccurate. The one I showed you before, where you do 120 pixels per inch for Diffusion Dither, will be much more accurate. So even though you might look on the computer screen at this one and say, this looks better, but it'll look far worse in the screen print. Important to understand. Any of what I've showed you here are options for you. None of what I'm showing you is what you must do. These are just options of how you can incorporate the computer into your screen prints.